So we are going to create a project. We're doing programming. We do it within the structure of a Java project. So we will do that, and we will use Maven as our main project structure. So because we're using Maven, we can do it in an IDE. We can create the entire project using Maven and the various wizards that are in the IDE. Or we can do it by hand by creating folder structures and a POM. Or we can do it using Maven itself. Now, I am going to do it using Maven itself, just for an example. I don't normally do that. Normally I will use the IDE to do it. But it's important to realize a few things about Maven as we do this, as we learn. Maven itself is a build tool. It uses a standard folder structure, and it helps us make our Java project workflows a lot simpler. So I can just do Maven clean compile, and that will get rid of all the compiled classes that I've got, clean the directory structure up, compile my code, show me any errors. I can package it up as a jar just with a single Maven package command, and I can run the test just by doing Maven test. So all of this makes it really simple to add into a continuous integration process. If you want more information on Maven, then the best place to go is to head off to maven.apache.org. And the Maven site has all the instructions that you're going to need. Quick start guides, instructions, the commands, frequently asked questions, anything you're going to need. If you look at Maven, you'll get a handle on it. Now in this course, we're going to use Maven. I'm not necessarily going to explain all its facilities, we're just going to use it to get stuff done. And we're not going to use much of it, we're mainly going to be using it to pull down the dependencies very easily. That will help us upgrade between different versions of Selenium. It will help us run our tests. So let's get started. I'm going to show you how to install a project the easy way, and the easy way is in IntelliJ itself. So I'm just going to start up IntelliJ. Then I'm just going to do create new project. Now we want to use Maven, so I'm going to choose a Maven project. I'm not going to select an archetype. I could do, but I'm not going to. If we do it from the command line, we usually use archetypes. I'm not going to bother here. And you can see it's picked up the JDK that we're using, so I'm just going to leave that. That's fine. Now do next. Now I have to give it a group ID. I'm going to say com.selenium simplified WebDriver artifact WebDriver basics, because that's the kind of course we're doing. Snapshot is fine. Project name, let's call it WebDriver basics. Now you can use whatever you want here, and you can change them later on, it's not a problem. Maven is prompting us that Maven projects need to be imported. I find it very useful to stick enable auto import on, so I generally do that every time this dialog comes up. It just means if we change the POM file, it will automatically update. That's very useful. So let's have a quick look at the project we've created. We have a typical Maven project here. We've got pom.xml. This is what you can see here, an XML file. It has the information we've added, but it doesn't have anything else. Maven uses dependencies, so we're going to add a dependency on JUnit in just a minute. You can see there are a .idea folder. This is where IntelliJ stores its files. If we delete the .idea folder and the WebDriver basics.iml file, then IntelliJ has no project here, but we've still created an actual Maven project in the source. Maven has a standard source folder structure. So we've got source main, source test. Main is where we'll put our abstraction layers. Test is where we'll write our test code. Then under both of these, we've got the Java folder because we're writing Java code. So what I should really do is add a dependency on JUnit. I'm going to cover adding WebDriver as a dependency later on, but just in order to make something happen, we'll add JUnit. If I was doing it from the command line and I was using an archetype, then JUnit would be in there, but we can do this nice and easily from the command line. So again, I'm just going to do a search
for JUnit. Most of the time I do web searches to find these things. JUnit is the unit test framework that we're going to write our tests in. It's basically a test runner, makes it easy to write things. So what we want to do is download and install. Now we're not actually going to download and install, we are going to add a Maven dependency. So all I have to do is copy this code, but I can't copy it directly into our project yet, simply because I do not have a dependencies section. Now you can see IntelliJ is using code completion at this point. It knows I'm writing a pom.xml, it knows what can go in a pom.xml, it's highlighted dependencies. If I just hit return here, it's filled that code in, it's written the code for me. So I'm going to just create the dependencies section in the XML format, copy in this code. Now you can see it's gone red, but IntelliJ has started to do things down the bottom. It's indexing. What that means is, because we've got enable auto import in, we've added this dependency in there, IntelliJ has spotted it, it has downloaded it, now we have installed JUnit. If I look in the external libraries here, you can see JUnit 4.12. JUnit is in here. I can now write code that uses JUnit. So I'm going to write a test in here. A new Java class, I will call it, what shall I call it? I'll call it app test. Simply because that's the old standard that a JUnit would not, the Maven would normally create as an archetype. So I've got a class at test. I'm going to create a test method. Every test method is annotated with at test. So if I say, oops, let's get this in. All enter is the autocomplete in IntelliJ, so it has magically brought in the import statement that I need. So I'm now going to say public void, and I will call it test app. And all I'm going to do is assert true, true. Now that's red, so I need to all enter static import method, and we'll static import method from the org.junit. That's the current place. You can see that there's another one in JUnit framework which is deprecated. Now when you see the code through this test, through this course, sometimes I will have coded it with JUnit framework, sometimes org.junit, because the code has been built up over time. When you're starting and you're coding, always choose the one that isn't deprecated. You will find that in the source code for the actual course, very few deprecated methods are used, and I will have changed the code over time. So I'm going to say assert true. Now we have a test. I should be able to right click and run this test. It's compiling it. And it's run the test, and the test passed, which is you'd expect because we're asserting that true is true. I'm just going to quickly change this to false, just so you can see what a failing test looks like. There we go, that test failed. So I'm just going to change this back so in the future it works. Now IntelliJ pretty much automatically saves things. So there we go, we've created a project from IntelliJ, created a basic pom.xml file that has JUnit. Now remember, throughout the course, because it has been built up over time, you will see pom files that have different versions. You should be using the most up-to-date version at each time. And remember, the easy way to change the versions is to go in your project, look at the pom.xml, open the pom.xml, change the dependency in there. If you're not sure what dependency to add, what version, do a web search for it, then you'll find the dependency code to add. Okay, I'm now going to show you how to add Selenium as a dependency. We don't have to download Selenium or WebDriver. All we do is we use Maven and add it as a dependency into the POM. So let's have a quick look. The way we find the current version is by heading over to Selenium HQ, Then on the downloads page, you can see there's actually a link for us, Maven users. So that's the first place we're going to go. So if we head over to Maven users, we'll see the actual dependency code that we can add. This is version 2.49.0. So I copy that. I add that into our dependencies section in the same place that I did with JUnit, just like this. Then you can see that that IntelliJ started to download the WebDriver. And all the dependencies have downloaded now. So now in the external libraries, I can see that we now have a lot more stuff, and I can see the Selenium parts are in there. Now this is all now ready for me to actually start automating with Firefox, because Firefox comes by default. So the other thing I'm going to show you is what happens if we're looking on the download page. We've already added it as a dependency, so all we do now is look down here and we see language version for Java. It's 2.49. Say I actually misread that. I think it's 2.50. I type in 250 here because this is how we will update it. It still remains red, right? IntelliJ has tried to find it, but it can't find it. It's told us down here the dependency is not found. So if I switch that back to 49, then everything is back to normal. And we have Selenium WebDriver ready to use in our project.
Time for a quick summary. We're using Maven because we're coding in Java. And when you're using Java, Maven makes some things easier. If you structure your project using the Maven directory structure, more people will understand your code base. They'll find it easier to approach because you're using the standard Maven structure. Maven, given the standard structure, makes it easier to package, compile, install dependencies, run tests, makes it easy to add it into the continuous integration. Selenium now supports Maven, so its releases are uploaded to the central Maven repositories for download. This makes it easy to keep your build process up to date with specific versions of Selenium. Some of the drivers are available through the main Maven repository. The Opera driver you can bring down through a Maven dependency. This makes it easy to include these different things in your build process. And you can quickly add this into your continuous integration just by a simple Maven test, and Jenkins and Hudson support Maven out the box. So we're using it because it will make life easier for us. I recommend you learn Maven in more detail because it will make your professional life a lot easier. One of the most common problems being reported in the forums at the moment are Maven problems. So I'm just going to spend a little bit of time over this video looking at what a good Maven build looks like and some of the most obvious Maven problems that people might be having. So this is my code base in here. I've checked it out of the repository. The first thing I'm going to do is get a command line up. Now I only recently discovered that in the top of the Windows Explorer I could type in commands to get the command line up and have it appear in the correct place. I've now been using this all the time, so I'm just taking a point to demonstrate that to you now. Now when we're working with Maven issues, we will do the vast bulk of the work from the command line. The reason we're going to do that is when we work from the command line, we only have Java and Maven that we're dealing with. Nothing else is getting in the way. There's no IDE confusing any issues. There's no other applications confusing anything. So we can work directly with where the problem is. So first of all, let's have a quick look and see what a clean build looks like, a good clean build. So the first thing I'm going to type in is Maven clean compile. I'm going to put in the option -d skip tests equals true. Now you do a Maven clean to get rid of the code that we might have compiled. Compile is going to put us through into the point in the workflow where it's actually going to compile the code. And to do that, it needs the libraries. Therefore, this is going to force a download of any libraries that are not there. I'm going to do a skip test equal true because I don't really want to run the test. I run the unit test. I just want to compile the code. So by running this command, it will cause a basic build to happen, a basic compile of the code, and it will cause us to download any dependencies. So you can see there, it's downloading the Firefox dependency because I removed the Firefox jar from my cache. Then we have some basic messages in there, and then we have a build success. So that's basically what a clean build looks like. We have to get in the habit of looking at the messages that come through in the build, because if anything went wrong in the download, it would tell me here. I would get a build error, but if anything went wrong, I have to look at the error messages that are up here. That's how we're going to know if there's a problem, and that's how we're going to know where the problem actually happens. Now, the simplest solution to a lot of our problems is simply to remove some of the jar files, the downloaded jar files, from the repository. So to do that, let me get an explorer over here. If I want to go to where my repository is, if I just type in, go off to the user profile, and the .m2 directory. So this is where my repository is, my local cached repository. If I go in there, we can start to see all the class paths that are in place for Java. Now if I'm having any problems, delete some of the directories in here and force it to re-download them. So if I'm having problems with Selenium, I might very well just come down here into org, Selenium HQ, and just delete everything to do with Selenium and force it to re-download. What I'm going to do in this case is just force it to download the Firefox driver. So by deleting that Firefox driver folder, if I go back to the command line where we're running, if I issue that command again, maven clean compile -d skip tests equal true, this time it would download all the parts related to the Firefox driver because I've removed it from my repository cache. So if you're having any issues with corrupt jars or missing jars or download issues, the best thing to do is try and do a maven clean compile -d skip test equal true to force a re-download. If you've got a corruption, delete the file first, delete it from the local cache repository, then do maven clean compile -d skip test equal true. So other commands we might be tempted to use, we might be tempted to force an update. This doesn't work all the time and doesn't necessarily do download all the dependencies that you're looking for, but if I do a maven clean compile and put in the -u, then do a -d skip tests equal true, I think that forces an update of the snapshots rather than the actual libraries, so it may not fix your actual problem. What we might want to do is a dependency purge. If I do maven dependency purge local repository, oops, then you can see it's starting to download the dependencies. So I'm forcing Maven to download the actual dependencies. So whether you want to do a dependency :purge local repository, or whether you want to just clean out the repository and do a Maven clean compile -d skip tests, that's up to you. Either one of those is a good approach for re-downloading the dependencies if you've got problems. So while that's going on in the background, basic things are Maven maintains all the jar files in the user profile.m2/repository. That's your cache. That's where Maven has downloaded all the jars that you're going to use. If you're having a problem with either missing jars or corrupt jars or something going wrong with your project, chances are you've got an issue with those dependencies. So what you do is you delete them and force them to re-download with a Maven clean compile -d skip test equal true, or Maven dependency purge local repository. That will then get your Maven repository in the right state where you can run the codes. And remember, we're doing all this from the command line, because then all the errors are obvious and visible, and all we're working with is Java and Maven. Nothing else is getting in the way. Once you've got things working at the command line, that's when you then move into the IDE, and that's when you then try and do things from the IDE. But do not try and fix your Maven problems from the IDE, because you will have too much stuff in the way and too many things getting confused. So now let's have a look at the proxy with the Maven. So if I head off to the Maven home, we can see that there's a settings.xml file in there. If I open that up with Notepad, or Notepad++ in my case, now in here there is a proxy setting. You can see that I have just taken this out of the comment and copied it in as a new one. I've added the name Fiddler because that's the proxy that I've got running. You don't need to change that from the optional, it's up to you. Normally you will be changing this because your workplace has a proxy and you want the details for that. I have changed it to go through a proxy simply in order to demonstrate the use of a proxy because I don't have one installed. So I have a proxy called Fiddler running, which is running on my local host and is on port 8888. I don't need a username and password, but they're being passed in, they're just being ignored. Now with this settings set up for Maven, if I come into Maven now, if I delete the Firefox driver over in the Maven cache, then let's see if we can show you this at the same time. Here's my Fiddler window, so you'll see, start seeing some web traffic coming through. And if I do a Maven clean, compile, skip tests, and there you can see the downloads coming through Maven appearing in the proxy. So Maven is currently going through a proxy. Now if you've got issues with the proxy, if you can't connect to it, it will tell you. So now I'm going to simulate some error conditions. So I'm going to delete the Firefox driver from my cache. Then I'm going to tell Fiddler to pass back a 404 on some of the pom files that Maven is looking for when it downloads it. So if I issue a normal clean compile, now we can see that there's a warning in there. We have to get in the habit of reading the error messages that are coming through. There's a warning in there for this particular pom. Now the build has completed with success, so that might not be an issue. Chances are it probably will result in an issue, but for the moment that's fine. What I'm going to do is make it a much more serious issue and not allow any of the Firefox stuff to download, so we can see what happens. So there we go, now got a build failure, couldn't execute the goals, managed to download some of the stuff. It's downloaded Firefox 2.5, it hasn't downloaded Firefox 2.32, that's a problem for us. So generally when this happens, we've had a download error, we've had a problem. What we'll do is we'll just keep trying to download it and see if that actually fixes the problem. In this particular case it won't fix the problem, so if I remove the actual problem, which I'm controlling by my proxy, and try this again, let's see what happens now. It should download with no issues, but the issue is it's not even going to try. Right, we've had a problem, Maven isn't even going to try and get those files back anymore, so what I have to do is force it to download the Firefox files, even though there is no problem with my proxy, even though there is no problem with getting it. I have to clear out this cache a little bit So I'm going to delete the Firefox driver there. Now, that's the only thing I've done. I've removed the files from the cache. I'm going to try this again. It's gone off, downloaded it, it's downloading it all properly now. Now it's worked. So the issue is when we encountered a single problem with the download, I had to go and fix the repository, move that stuff from the repository in order to force it to a download again. So you could do the dependency purge local repository command, or you could just delete the files. You could try and do a -u, but essentially you have to work at the repository level first to fix it in order to get Maven to refresh. In this video, we're going to have a look at the folder structure for IntelliJ, specifically so we can look at which files we would add into version control and how to delete the files if IntelliJ ever corrupts. The reason I'm going to delete the files is so that I can demonstrate the import and open function in IntelliJ, but periodically you might have to do this. So let's get a file explorer up. Okay, so this is the basic folder structure we have for our project. This is the pom.xml. This is important for our project. These are all our dependencies. This is the source folder where we have all our Java source. Target is the folder that's created with all our class files from Java. The IntelliJ files are the .iml file and the .idea folder. For version control purposes, I typically only ever add into version control the pom.xml and the source file. I don't add the IntelliJ configuration because people like to configure their development environments differently, and I don't add in the target because that's really temporary compilation work. And as long as we've got the source in there, we can recompile and work with there. And it helps keep the version control repositories of a smaller size. So in order to make this a clean project with no reference to IntelliJ, I'm just going to delete the .idea folder and the .iml file. Now, it's as though we've been working with Maven and Java from the command line, because target will be created when you run Maven test or Maven clean compile at the command line. And that's it. Now we have a fresh folder with no IntelliJ. So if for some reason IntelliJ can't open the project because you've added some plugins, the plugins no longer work with a version of IntelliJ, whatever you've done, just delete the .idea folder and the .iml file, and then re-import or open the project again in IntelliJ to start from scratch. So we have a project. It's just to set up the POM file and the source file, so it's a basic Maven project. And now I'm going to bring this into IntelliJ using the import project wizard. So I click on import project, having opened up the IntelliJ. So this basically says select directory with existing sources, i.e. the folder that's got the pom.xml. So I'm just going to copy this here. Then we've got the folder. That's the folder that's got our pom.xml in. Let's just double check. So I'm going to say OK here. Now I want to create project from an external model, Maven. Now this can seem confusing, but we'll just keep this to the basics. So we're going to make an IntelliJ idea directory folder, so it will create the .idea folder and the .iml file. I'm going to say import Maven projects automatically, so if we change the pom.xml, that will work. I'm going to say automatically download the sources and documentation. When you start using external Java libraries, this is quite useful because we can then view the source. So when we're working with WebDriver, we can view the source for WebDriver, and that will help us with our ongoing learning. Let's say next. So I'm just going to say yes, that's the one we want to import, the snapshot. Now generally at this point, I'm just keeping to the defaults. So when you import the source code that comes with the course, just stick to the defaults. The important things are on that first screen where you say, yes, download the sources, etc. So we want to use the JDK 1.8 because that's what we've set up in IntelliJ. There's the project name, that's all fine.
So you can see there in the folder structure it's created the .idea folder, and in a minute it'll create the .iml file when it starts up. Close the tips. Now it's just checking whether we've got all the dependencies in WebDriver. So you saw there's an extra step where it was downloading the source code because we hadn't set that up before. Now it's scanning it, and there we go, we're good to go. We've imported this project into IntelliJ. There's the source. And this is the very simple JUnit test that we created before with the WebDriver dependencies in the POM. So that's that imported. And as I exit, you can see that we've also created a .iml file as well as the .idea folder. So I've started IntelliJ. We have a blank folder. It doesn't have the IntelliJ folder files in it. It's just got our source and our pom.xml, so we're ready to bring this into IntelliJ. And this time I'm going to use the open function. This is usually a little bit simpler to get working with. So again, I'm going to take the root folder there, copy that in there, and it's found the pom.xml file for us. So it's opening that up. And it's scanning the files and everything else. And we should be good to go very quickly. The main difference between the open and the import is that the open is just working from the pom.xml. It may not find your JDK properly. It may not find certain parts and pieces of the puzzle here. If that happens, what you do is you go in here into the main project, right click, and use the open module settings. And then you have access to all the modules, the JDK that's being used, the different facets of Maven, and the configuration that the import function walked you through. Normally, after a certain period of time work with IntelliJ, the open should work just seamlessly. If it doesn't, use the project structure editing, the properties editing to fix everything up. But the open is usually faster and easier to get started with than the import function, but it may require a little bit extra setup. Most of the time you won't have to, and it'll work just fine. But sometimes people get confused with the import, and the open is a lot easier to work with. So that has opened and run fine. We're good to go with the open. We're about to go through the process of writing our first test. Don't worry if you don't understand what you see on the screen now. I will explain it over the next few videos. The first test we're going to write is going to be fairly simple. It's going to open a browser, visit a website, and check some text in the title. Now, WebDriver uses the concept of a driver to interact with browsers. Firefox driver, Chrome driver, IE driver, etc. Essentially, this is a common interface so that we can treat all browsers the same, and we don't have to code specifically for Firefox or write custom code for Chrome. That's the idea, and it pretty much works. Now, when WebDriver was first created, HtmlUnitDriver and Firefox driver were part of the Selenium Java dependency. So as soon as you added Selenium Java artifact to your pom.xml, you could use Firefox or you could use HtmlUnit. WebDriver is changing. The drivers are moving out of Selenium WebDriver to be managed as separate dependencies. The first browser we're going to use when we write some code is going to be a headless browser called HtmlUnit. A headless browser means that you won't actually see the browser open because it doesn't render on the screen. That means it can sometimes be faster to execute code which is using a headless browser. So we need to use the HtmlUnitDriver, and that's now been moved out into a separate project. In version 2.53 of WebDriver, HtmlUnitDriver was moved into a new project on its own, which means that we don't have access to it just by adding Selenium Java as a dependency. So before we can use it, we have to amend pom.xml to add it as a dependency. Now, if you're using a version of WebDriver below version 2.53.0, then you won't need to add HtmlUnitDriver to the pom.xml. But when you come to use Firefox in the videos almost immediately after this one, your test probably won't work because the version of WebDriver won't be good enough to work with Firefox. So I advise you to update your Selenium WebDriver to the current version listed on seleniumhq.org and to add the HtmlUnitDriver as described on the HtmlUnitDriver page, which is on GitHub. Now, the benefit of having drivers in projects on their own is that they can be updated without a major WebDriver release, and they can keep up to date faster with the actual browser versions. For example, we always used to have the issue that WebDriver needed a new version when Firefox was updated, because the driver is part of WebDriver. And the version of HtmlUnit that WebDriver used lagged behind the actual version of the HtmlUnit project. Now that HtmlUnitDriver is a separate project, hopefully we'll see it using the most up-to-date version of HtmlUnit and staying up to date with the HtmlUnit project as well as the WebDriver interface. And all of that was a way of saying we need to update pom.xml before we can create our first test. So we'll do that now. Let's visit the HtmlUnitDriver homepage, and that will tell us what we have to do to add HtmlUnitDriver as a dependency in our pom.xml. So this is the HtmlUnitDriver homepage. It's on GitHub, github.com/seleniumhq/HtmlUnitDriver. So documentation is telling us that this is what we need to add to use HtmlUnitDriver. Now this Selenium API, Selenium support, is equivalent to the single dependency that we've already added, the Selenium Java dependency. So all we need to add to our project is this section here about the HtmlUnitDriver. I'm going to copy and paste this, copy it from the HtmlUnitDriver page, paste it into the dependency section of the pom.xml. You can see IntelliJ is updating. It's downloading the HtmlUnitDriver version 2.20. The version that you add may be different because remember these dependencies, these versions update over time. So now I've got HtmlUnitDriver in my project, and you can see that my code is now ready to run. You won't see that yet because you're not at this stage. But what we've basically done is made it possible now for us to use the HtmlUnitDriver in our code. So when you start coding against it in the next few lectures, you won't see any of those red underline errors in your code. So if you edit your code, do what I've just done, copy and paste in the HtmlUnitDriver, then we'll be good to go.
So now it's time to really get started with WebDriver, and let's create a test that will do something to a website. Now the website I am going to choose, just an example, because it's completely under my control and I know what it is. I'm going to go to compendiumdev.co.uk/selenium and check that the title starts with Selenium Simplified. That should be simple enough. Now when you come to do it, you can do this completely exactly as we're going to do it now, or pick your own website, pick a different title. It's up to you. So I'm going to start by renaming this test class. So to rename it, I'll do a rename refactor, and I will call this first test. which is renamed the class name, which is fine. We still have JUnit in here. We still have our assertion. Now I'm going to call this test driver is king, because in WebDriver the driver is the king. Everything that we do is going to be based around a driver. So as an example, so in Selenium, the server is the king. The server is the thing that we're sending all our requests to and making everything happen by virtue of having a Selenium server running. When we use WebDriver, everything works by virtue of having an instantiated driver that we can make commands on. So I'm going to instantiate something as a WebDriver. So I'm going to use the WebDriver interface as my main class here because I don't want it to do anything special. And I will instantiate that as an HTML unit driver. So WebDriver has a bunch of drivers available to us. We've got the HtmlUnitDriver. The HtmlUnitDriver is a headless driver, which means that when we run this test, no browser will be displayed. We also have the Firefox driver, the Chrome driver. Firefox drives Firefox, Chrome drives Google Chrome, there's an IE driver, there's an Opera driver, various mobile drivers. We're going to start with HtmlUnitDriver. It's built in, nice and simple. So I have instantiated a driver, then I have to tell the driver to go and get http://www.compendiumdev.co.uk/selenium. That should go off, retrieve that page for us. And then I'm just going to check that it is true that the driver dot get the title, which returns a string, starts with Selenium simplified. So that's a fairly simple test. If I run that, I'm just going to right click, run that. Test passed. We didn't see any browser. So how do we know that the test actually passed? Well, let me change this so that that is no longer what the title starts with. The test should fail. Great. Now HtmlUnitDriver is very simple to get started with. It's headless. The tests run very, very quickly. So if you're testing something very, very simple, very basic with HTML, HtmlUnitDriver may be all you need. You don't have the visibility of the actual test running, but if you make sure that your asserts are good enough, that cover the right thing, then you can be satisfied that your test should run fairly reliably and fairly quickly. So that's it. That's all it takes to get a simple test running in WebDriver. Now I spent a little bit of time exploring the code that we've done here, just so that we get a little feel for some pros and cons, even just at the start. So at this, you can see here, I have chosen to use the WebDriver interface rather than the HtmlUnitDriver. I could have just as easily done this. HtmlUnitDriver is an HtmlUnitDriver driver.get the page, then assert true the title. This is equivalent. Now, the reason that I put the WebDriver in here rather than the HtmlUnitDriver is that we may want to, in our tests, inject the driver. So have the driver itself instantiated somewhere else, because we may want our test to run across Firefox, Chrome, Opera, HTML unit. We may want them to work against a remote WebDriver. And if I make all my tests use an HTML unit, expect an HTML unit driver, then I won't be able to do that. I won't be able to inject it. But if I get used to working with the driver interface itself, then I will be able to later on refactor the test much more easily to use the generic interface. Now remember that WebDriver itself is becoming a standard. So the interface, this WebDriver object, is becoming standardized. The actual driver itself may have additional commands on it, but that's for each driver to decide. So what I'm going to do is have a quick exploration of some of these classes. Because we're early days yet, you've seen essentially two commands. The get command, which is one of the basic navigation commands, and the get title command. Now if I do a code completion on driver here, so that was a control space in IntelliJ, you can see we have these basic commands at the top driver level. I can get a page, I can get the title, I can find an element, I can navigate through to different pages, I can quit the browser. Now I didn't have to quit the HtmlUnitDriver here. When the driver object itself closes down, it closes down for me because it's a headless driver. Other drivers I will have to quit or close with the test. You can see I can get the current URL, I can get the page source, get the window handle. So there's a variety of commands that I can do here. Now if I, in IntelliJ, control and left mouse click through, you can see that I can start to look at the source code for WebDriver. Now that is going to be, it's always going to be, the most up-to-date documentation that you can find for WebDriver. So get in the habit of looking at the source code that implements WebDriver. Now, HtmlUnitDriver itself, if I do a Control P on that, you can see that I can specify a browser version, whether JavaScript is enabled or not, and various capabilities. I'm not going to explore this at the moment. We'll cover drivers in more detail later on in this course. But you can see that there is more than just instantiating an HtmlUnitDriver. I think by default JavaScript is not enabled with HtmlUnitDriver. HtmlUnitDriver has its own custom JavaScript interpreter, so it may handle JavaScript differently than other browsers. So we have to get in the habit of using the right browser for the right type of testing. HtmlUnitDriver is great for checking the basics of pages. If I want to just go to a page, check the title, HtmlUnitDriver is going to be fine. If I want to go to a page, pull off the source code, do something on that, HtmlUnitDriver is going to be fine. And it's going to be fast to start up and instantiate. If I want to check various AJAX calls, HtmlUnitDriver may have some difficulties because the JavaScript processing is going to be different. So it's fast, it's good for very simple testing. And get in the habit of looking at the source code. Okay, so I just want you to spend a little bit of time on your own and experiment with your IDE. Just learn a little bit about what to do. I'm going to quickly show you some of these things that are up here, but I want you to just play with it, look at the help file, get a feel for what you're doing, and have a little play around with the test, experiment with it, change the URL in the test, rerun it, check for different text, rerun it, use different string commands, do something else, just have a little play with it, spend 10-15 minutes, just get a feel for the code and own this code that's in here. Okay, so type it into your IDE, have a play with it. So the hints and tips I want to give you for IntelliJ at the moment are, if I click on this, the configure project icon, you can see these auto scroll to source, auto scroll from source. These are quite handy in the sense that when I am viewing the code for the WebDriver, if I control click through to it, you see that now the source code is shown in the left here on the project. This means that I can actually start scrolling through the source code and see what else there is. It's taking me to WebDriver. Next to it is a WebDriver exception. I might want to have a look at that. I might want to have a browse around the code. Do that. Have a quick browse around the code. In your test, experiment with the code completion. In IntelliJ, control space shows the code completion that I can do for that particular object. Get a feel for that. I can look at the Java doc in IntelliJ with control Q. So I'm on a command, I hit control Q, I can see the documentation for it. Try that on the different commands we've got. See how far you get. In the commands themselves, I can do control P and it will show me the command completion. Just get a feel for some of the things that you can do. So just to remind you again, spend a little bit of time setting up your IDE, learn your IDE, familiarize yourself with the simple test, change this test and play with it. I'll see you back here in about 15-20 minutes.
So up until version 4.5, version 45 of Firefox, we had a very easy decision to make when we were trying to automate it. We essentially just used the Firefox driver, and that was built into WebDriver. So versions of Firefox driver prior to version 46 used the Firefox driver built into Firefox. All the code in this course has been written and tested using the Firefox driver and versions of Firefox below 46. But time moves on and WebDriver changes, and a new Firefox driver called Marionette will be used for future versions of Firefox. So you have a choice. You can fix your version of Firefox to version 45 using the extended support version until the Marionette driver is stable, and keep using the Firefox driver. So you can always download older stable extended release versions of Firefox from the Mozilla site and use those quite happily. Or you can use the most up-to-date versions of Firefox that update themselves automatically and use the Marionette driver. I'll show you how to use both drivers in the next few videos. Be aware that most of the videos in this course show code using the Firefox driver, but every time you see Firefox driver in the code, you can change it to Marionette driver or leave it at Firefox driver if you're using an appropriate version of Firefox. If you use the Marionette driver, then you might find that some of the code does not work because the Marionette driver is still fairly new. This will change over time as the Marionette driver gets better. So for the moment, I've added a list of the tests in this course that fail in the Marionette driver in the lecture description of this lecture. All of the tests work with Firefox driver and with version 45 of Firefox. But over time, that will change. Marionette will be more stable and the tests will all run under Marionette. The reason this is a decision for you is that you're just learning. So if you see errors, you may not know whether they are related to your code or the Marionette driver. So I'm going to recommend that if you can, you stick to version 45 of Firefox. Then you'll know that if there's any issues, it's with your code and not the browser version and not the Firefox driver or the Marionette driver. Now, it might not be possible for you to run version 45 because you might have to use the most up-to-date version for your testing, in which case you might try using a virtual machine with Firefox 45. Now remember, this is just a temporary situation until the bugs with Marionette have been removed. Unfortunately, it doesn't make things easier when you're just learning and don't know if you're facing a code bug or a Marionette bug. But you'll see both drivers in action in the next few videos. You do have options. You could keep using Firefox 45, you could use a virtual machine, or you can just use Marionette and hopefully it will be better by the time you come to use it. So version 46 of Firefox is changing the way that we automate it with WebDriver. Prior to version 46, we used the Firefox driver that was built into WebDriver. And if we want to keep using that, all we do is download version 45 of Firefox from the extended support page. This is the Firefox extended support release page on Mozilla, where we can download the older, stable versions of Firefox that don't update. This is the easy way to continue using the Firefox driver. For Firefox versions above 45, we'll use Marionette. Marionette is the new driver that's been set up by Mozilla. There's a page on Mozilla describing the Marionette project. The main page we're interested in is the WebDriver page. That's the one that has the instructions for setting up Marionette and using it. So with older versions of Firefox, all we do is download Firefox and instantiate the Firefox driver. This won't work with versions 46 and above. So we have to use Marionette. So we download the executable from their WebDriver page. We unarchive it to a directory, we rename it to wires.exe and add wires.exe to the path, and then our test is very simple. Instead of using the Firefox driver, we use the Marionette driver, and I'll show you all this in the next video. That's the simple way of doing it. There's another way of doing it which you will see in the source code, where I don't rely on the wires.exe being added to the path. I set a property in the code that points to the wires.exe. And then I instantiate a Marionette driver in order to start up and control Firefox. This is just a little bit more advanced than adding it into the path, and you get to choose which one you want. Your choice is essentially stick to version 45 and use the Firefox driver, keep updating Firefox and add the Marionette wires.exe into the path, and then just use the Marionette driver, or control it all in code, as you can see in front of you here. So use whichever one is easier to get started with. In the next video, I'll show you this inside the IDE with actual code. So in the IDE now, if I want to work with the Firefox driver, this is all I have to do. I create a simple test, WebDriver driver equals new Firefox driver, open a page and start. Now this is explained in the Firefox lecture that follows. So I ran that test, Firefox started. What we're going to do is we're going to use the Marionette driver. Remember, this is the one that will work with versions of Firefox above version 45. So I go to the Marionette WebDriver page. I download the Windows executable, or whichever one we're using. So the archive basically just consists of one file, wires win.exe, with the version of the driver being shown in the file name. So what I want to do is unarchive this into a place on the drive. Now I typically do this in a tools folder in the project. So you can see here's my project folder with the pom.xml and all the source code. But as a peer project to that, I've got a tools folder. That's where I store all my drivers and any other supporting things. And in here I've got a Marionette folder. So what I would do is just take the version of the executable from the archive and add it into that tools folder. Then I rename this to be wires.exe so that in my code I'm only ever referring to wires.exe. Now the easy way to get this working is to add this wires.exe into the path. So for the path settings of my computer, if I go into the environment variables, find the path, edit it, and at the very end of this path, if I just add the Marionette folder with wires.exe into that path, do OK, 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 I'll have to close the IDE down and start it again so that everything takes effect. So now, instead of using the Firefox driver, I would use the Marionette driver. And since that's in the path, I should be able to just run this test. So, the documentation told us that we could just add it to the path and it would work fine. What we're seeing here is that we have to do it the more complicated way, which isn't actually that hard. So the reason I add it into a tools directory relative to the project is that this line here tells me the path that my project is stored in. So if I say system.getProperty for the user directory, that is giving me the path that this project is stored at. So that is giving me this path where the source code and the pom.xml are stored. Now if I go up a directory, we can see the tools directory, then we can see the marionette folder, and that's where wires is. So this next line says, take that path, go up a directory, go into the tools, go into marionette, and use wires.exe. Then set system property WebDriver.gecko.driver that the marionette driver is expecting, and use that as the marionette driver location. So now, when I run the test, WebDriver started up and ran the test using the marionette driver. So in the code, if you see in any of the lectures me writing new Firefox driver, instead just replace it with this, the way of getting your marionette driver location, and then instantiate a marionette driver instead. Then we'll be using a version of the Firefox driver that works with versions of Firefox above version 46. Or if you want to keep it simple and keep using the Firefox driver, then we need to make sure that we install the extended support release edition of Firefox version 45.
Okay, so let's use a real browser. HtmlUnitDriver clearly is a real browser. HtmlUnit is a real browser. It's just headless. So let's use one that we can see running. This will be super exciting. So let me just create a new test for this. I'm doing copy and paste. This is bad because now I have code duplication, but we'll cover refactoring later on, I'm sure, in one of the lectures. So let me just do Firefox is supported by WebDriver, because it is. And the way that it is supported is through the driver. So if I create a new instance of a Firefox driver here, there we go. I've now got a test that will instantiate Firefox, go off to the page, and check the title. So let's try that. Let's see what happens. So there we go. A couple of things there. Firefox took a lot longer to start. On my machine in particular, for whatever reason, Firefox takes 10 to 15 seconds to start up. Yours may start faster. The other thing is, you can see here the test has stopped, the test has finished, the test has passed, and I still have a browser window open. That will be a killer if I have more tests. So what we have to do, driver.close or quit. So driver.quit will close all the browser windows that are open. Driver.close will close the window that's open. Let's just double check what the docs say about that. Control Q. Driver.close, close the current window, and it will quit the browser if it's the last window. Driver.quit will quit the browser and close all the windows. Now we didn't have to do this with HtmlUnitDriver because HtmlUnitDriver is headless. Everything is within the same thread, it all works fine. Firefox driver starts up an entirely new process and we have to tell it to stop. And that's where the close comes in. So there we go. This now, let's run it, let's check. There it is, Firefox is running and closed, all through the test. So there you go, that's how to start with a proper driver. Feel free to experiment with a Firefox driver. From here on out, we'll be starting to work with real browsers.